Ladies and gentlemen, welcome back. Today we're going to start our unit on solutions. And this first video is more conceptual. There's no math in this at all. So, we're going to talk about a couple types of mixtures. And we talked about two types of mixtures this school year. And we'll get to that as we go through this slide. So, you know from experience that sugar dissolves in water. And sugar is described as soluble in water. Second here. Okay, and by soluble, we mean capable of being dissolved. So when sugar dissolves, all its molecules become uniformly distributed among the water molecules. The solid sugar is no longer visible. Such a mixture is called a solution. And a solution is a homogeneous mixture, which we talked about way back in September, of two or more substances in a single phase. Remember, homogeneous, one phase. Okay, the dissolving medium in a solution is called a solvent. And the substance being dissolved in a solution is called a solute. And remember, our universal solvent is water. So, solutions may exist as gases, liquids, or solids. There are many possible solute-solvent combinations between gases, liquids, and solids. So an example, an alloy, which is an alloy is a mixture of metals. Are solid solutions in which the atoms of two or more metals are uniformly mixed, as I just said. And a couple examples, brass is made of zinc and copper, and sterling silver is made of silver and copper. Here's a slide of a few types of solutions. Right here we see a liquid solute in liquid solution, so ethanol molecule in water. And here we see a solid solute in a solid solution, so we have gold and silver, 14 karat gold ring. So now, we talked in the last couple of slides, we talked about homogeneous solutions. Now we're going to talk about heterogeneous solutions. So if the particles in a solvent are so large that they settle out unless the mixture is constantly stirred or agitated, the mixture is called a suspension. So for example, a jar of muddy water consists of soil particles suspended in water. The soil particles will eventually all collect on the bottom of the jar because the soil particles are denser than the solvent water. And just a fun fact, particles over 1,000 nanometers in diameter to 1,000 times or 1,000 times as large as atoms, molecules, or ions, they form suspensions. Now, after a suspension, we have a colloid. And a colloid are particles that are intermediate in size between those solutions and suspensions. They form mixtures known as colloidal dispersions or just simply colloids. So the particles in a colloid are small enough to be suspended throughout the solvent by the constant movement of the surrounding molecules. And colloidal particles make up the dispersed phase, and the water is the dispersing medium. So an example of that would be mayonnaise. Mayonnaise is a colloid. It's an emulsion of oil droplets in water. So the Tyndall effect. So many colloids look similar to solutions because their particles cannot be seen. So the Tyndall effect occurs when light is scattered by colloidal particles dispersed in a transparent medium. I like to remember the Tyndall effect just like this. It's just the scattering of colloidal particles. Right? So this definition, if you understand what the the Tyndall effect is, you're thinking, that word colloid is in the definition of Tyndall effect. What's a colloid? If we understand what a colloid is, then we'll be able to understand what a suspension is. So those three go hand in hand. An example, a headlight beam is visible from the side on a foggy night. That's a colloid, right? The Tyndall effect can be used to distinguish between a solution and a colloid, and that's what we're going to look at next page here. So we see, in this first one here is just a solution. We don't see a homogeneous solution. We don't see anything going through this jar here. Here we see the scattering of the colloidal particles, right? The Tyndall effect here, which makes this a colloid. Now, something we've talked about already, but we're going to review a little bit. Talked about electrolytes versus non-electrolytes. If we were in class, I'd ask students to raise their hand. What's something that we drink that talks about electrolytes? Hopefully, some students would say Gatorade, Powerade, Pedialyte, so forth. Body Armor, my favorite. Non-electrolytes, right? Soda, juice. Okay. In everyday life terms. Now we'll get to the chemistry of it. So, a substance that dissolves in water to give a solution that conducts electric current is called an electrolyte. And any soluble ionic compound, such as sodium chloride, is an electrolyte. And the positive and negative ions separate from each other in solution and are free to move, making it possible for an electric current to pass through the solution. All right, so if you have an ionic compound, electrolyte. Now, a substance that dissolves in water to give a solution that does not conduct electric current is called a non-electrolyte. So sugar is an example of a non-electrolyte. So neutral solute molecules do not contain mobile charged particles, so a solution of a non-electrolyte cannot conduct electric current. So an example of this would be molecular compound. And we know from our vast study of naming and writing formulas, a molecular compound, two or more nonmetals. And the reason I say two or more, because we could have a sugar. Now this next page, right, it says electrical conductivity of solutions. And this was one lab we'll do in class. So we look here. Now, if we have an electrolyte solution, this light bulb is going to go on. So first off, we'll name everything here. So sucrose. So we have it right here. We have C12H22O11. And we know that's a molecular compound, right? It's a sugar. And we see this light bulb did not go on. The acetic ion now, the light did go on here, so this is an electrolyte. It's just not it's not a strong electrolyte. So it's pretty dim. This, no chance. There's life here, so this is an electrolyte. This is a non-electrolyte. Now, sodium chloride, we have a lot of power here, so we definitely have an electrolyte here. We're not going to classify them strong, weak electrolyte, just electrolyte or non-electrolyte. And hydrochloric acid, the light bulb's about to break. There's so much energy here. So we see here that this is an electrolyte. Okay, so now, from our reactants here, or our compound, do we have an electrolyte or non-electrolyte? Key thing to remember here, so electrolyte, yeah, that's pretty dark. There we go. So electrolyte, ionic compound, non-electrolyte, molecular compound. So NaCl, we know, sodium chloride, ionic compound, electrolyte. HCl and H2O, we just saw this last slide, or last page. Hydrochloric acid was the strongest one, the strongest electrolyte. KOH, potassium hydroxide, once again, an electrolyte. And then the last one, C12H22O11, which is sucrose. And sucrose is a sugar, and we know that sugars are not electrolytes. And this concludes our first video on solutions.